Now we move on to two-tailed tests. Welcome to the video, by the way, and just saying I am just a year 13 trying to help out for year 12s, and yeah, this is not going to be a long-term maths channel, just a temporary maths channel perhaps. And if there are any specific videos you want me to make, I will try my best to make them, although I have a bunch of videos I hope to make. And yeah, so two-tailed tests. Oh, by the way, if you haven't watched the first and second part, don't forget to watch them. I know they're long, but you know, it's worth it if you want that A and A star. But also you should check out other videos from teachers, which probably might be more accurate. This is just my experience, my learning, and yeah. So two-tailed tests is basically, this is going to be a quick one, hopefully. It's the same, the method you use is the same as one-tailed test. The only difference you need to know, and the steps are the same, like, yeah, the steps which I mentioned in all the other videos are the same. Basically, all you need to know for two-tailed tests is that, what colour did I use? It's a hypothesis that doesn't have a direction. And basically the most common phrase, the most common phrase the question will use is no change. They will say something and say that they believe that they'll have no change, or they might not mention anything, basically. Or they might not mention anything about
either increasing
like increasing, more, decreasing, decrease, less, blah blah blah. Basically, when you're confused, you don't know if it's increasing or decreasing, it's likely that it's basically no direction. And you just basically, I realise I say basically a lot. Comment if you think that is right and I need to change it. But basically, you write. Okay, sorry. So yeah, it's about hypothesis. So H1 is always going to be P does not equal to X, and basically normally X is going to be like H0 P equals X. So you use the same X. Okay? And what you need to know is that you have to either double the p-value for your observation or halve the significance value, the significance level at the end you are testing. At the end you are testing. Now I was never taught doubling the p-value, so I can only say in this video about halving the significance level at the end of your testing. So basically what this means is that, for example, I'm just going to write it here, but I'm going to get it, I'm going to rub it out later. So for example, they ask you that the question, 5% significance level, and there's no change. All you need to do is basically all the questions are exactly the same, and the only thing you need to change is just, instead of like probability x is less than a is less than 0.05, you need to do probability of p x is less than a less than or equal to, that I made a mistake again in front of you guys, embarrassing. For binomial, you have to remember that it's always less than or equal to a and not less than a. That's normal distribution, which you learn in year 13. So yeah, two-tailed test, the probability of, instead of probability x is less than or equal to a is less than 0.05, we have to do is just the probability x is less than or equal to a is less than 0.025. So basically you divide that by 2, and then you have to do probability x is bigger or equal to another value, b, is less than 0.025. So no change, two-tailed. Two-tailed means there is two directions. So two directions mean one direction is that p is bigger than a value and p is less than a value. And that is all you need to know. And let us do a question from the book so you can see it in action. Remember, do all the questions in the book, minimum, and then there are tons of questions everywhere online, tons of questions in workbooks. I used lots of workbooks and I'll link it all in the description so you can check them out, and I recommend you getting them because they are really helpful. And like as many questions, like just do as many questions as you can. So let's do question 8 of 7D. So before I let you guys do it yourself for a while, I'm just gonna copy the steps for, to a hint, I guess. I mean, it's best if you don't look at this, but if you need it, then it's totally okay because it's all about, practice. So here you go. And 2 minutes and I will come back and explain everything. Okay, so again, we will scan the question and check out any good bits. So 1 in 10, again, it's always like the first thing. The first thing is H0, 1 in 10. So that's not 0.1. Please. The production process is modified, so just to, I guess, explain a little bit more, like, modified. So, how these questions are laid out often, 99% of the time, how these questions are laid out is, no, they will tell you H0 normally, very straightforward, and then they will tell you the events, so e.g., to new manufacturing process, for example, new production process, new production, So they would tell you H0 and then they would tell you an event. So for example, something they did, an action. So an event or an action. So something they did, like a new production process. And then they will say, the sample and the outcome after the event. And then they will tell you this. Then they will tell you to test at X significance level, and they will also basically kind of hint at what type of hypothesis. To use. Basically.
Yeah, so that's how all the questions are kind of laid out. But then you get some really weird exam questions, and I don't know why they have to be so mean sometimes, but yeah, guess that's life. And I mean, I can't really say because my exams are cancelled, so.
Okay, so that's just a quick idea. I thought it's good to know roughly what these questions look like, and before you kind of, I guess, do it. So 1 in 10, we've got the null hypothesis, and then we are told the sample. So this is a binomial. So sample of 20, so basically, when you see sample, it's a hint to use binomial. It's a hint to use the binomial distribution. Actually, is it? Well, I don't remember, because I haven't checked out normal, but if you're in year 12, I think, if you're in year 12, then remember this if you can't really remember. Yeah. I don't think I'm right in this, but it still counts. But it might also be to use normal distribution, but we'll talk more about that in future videos. And then you are told the result of the new process. And then you're told to test at the 10% significance level. The hypothesis that the proportion of cracked balls has changed as a result of the modification. So changed is basically telling you that you need to use a non-direction or two-tailed hypothesis. So how do we do this question? Using the steps and the tips, you formulate it. So let X be the number of cracked balls. Let X be the number of cracked balls, and then you identify the hypotheses, H0, P equals 0.1, as here, and h1 p does not equal to 0.1 because it's a two-tailed hypothesis this time. And there are different methods you can use, but in this one I'm going to use a method where you need to find the critical region, and check if the results, in this case 1, lies in the critical region. Yes means we can reject h0. No means we accept h0. And this should
be in a different colour. And it should be smaller.
So the probability that x is bigger or equal to a is going to be less than... I missed something very important, but I will get back to that after I say this. Is less than 0.05, and the probability that x is less than or equal to b is less than 0.05. Okay, so remember that 10% significance level, you divide by 2 when using a two-tailed hypothesis. Yeah. And what I forgot to say earlier is, for here, x is a binomial distribution where n is 20, p is 0.1, assuming h0 is true. And now you can basically try numbers using your calculator, and also remember that the probability x is bigger or equal to a equals 1 minus the probability x is less than or equal to c, which is not b. Okay, so that's another thing to bear in mind. And what you will find is that when px is less than or equal to 0, it equals 0.1216, and this is obviously less than 0.05. Oh wait, sorry, that's not obviously. It's obviously bigger than 0.05. And the probability... And because we are already at 0, this means that... Let's use yellow. So we are already at 0, and the value, and the critical, and the value I think, not the critical value, or the critical value? And the value is still bigger than 0.05, therefore there is no lower tail. There would be a low tail if there was a value that's bigger than 1. I think I can just cut this. That's bigger than 1 and, less than 0.05. So for the upper tail, the probability that x is bigger than or equal to, if you use 5, which is the same as 1 minus the probability x is less than or equal to 4, equals 1 minus 0.8670. Remember to write out every step because you can lose method marks easily, and you can gain them easily as well. It could easily be a 1 grade difference if you, write a bit more steps than not. And yeah, so 0.133 is bigger than 0.05, which means it's not the answer. So we try a different one, but it's close, so we try 6, which is 1 minus the probability x is less than or equal to 5, which is 1 minus 0.9568, which is 0.0432. And this is less than 0.05, which is right. And so the conclusion, therefore, is that x is bigger or equal to 6. And now, because the question is asking you to...
Oh, I didn't realise I didn't brush that. That's sad.
Okay, so do not stop here. Okay, so remember to look back at the question and think about context. Always think about the context, because that's where I think examiners like to test people. If it's in psychology A-level and maths A-level, they always like to use context, and I think it's the easiest place to lose marks, but also the easiest place to gain marks. So the conclusion is that we found 1. So 1 out of 20 is broken, and we found that the critical value is bigger than or equal to 6. And 1 does not lie in, okay? So yeah, so context. Let me just, no, it's easy, context. And so 1 does not lie in the critical region, which is x is bigger than or equal to 6. So there is insufficient evidence to reject H0. But we, again, don't forget, link it to the question. Do not forget to link to the question. And basically that just means that, therefore, there is no reason to doubt. Doubt? How do you spell doubt? To doubt that p equals 0.1. So basically, to say it in my words, there's no reason to doubt 0.1, and that 0.1 is accurate because it's not due to chance. So the proportion of cracked bowls has not changed. It has not changed because you accept H0. So sometimes you might find that it has changed, and if it has changed, you have to really state the direction. Okay, so if it has changed, you should state whether it has increased or decreased. Okay, so basically you just follow the steps as I showed before, and you just use the two-tailed hypothesis, and there's nothing really different, is there? So as long as you remember the steps, remember the type of questions, because there are only so many questions they can ask. In the hard questions, they do like to add a bit of mixture of like probability and stuff, but that's in like A2 stuff. So for now, you are safe. Lucky you. And
that is the whole of hypothesis testing done. Wee. Yeah, hope you enjoyed it. Like if you liked it, and if I said anything wrong, please comment because I do not want to give false information. And yeah, bye bye.